Today we're going to finish lesson 6.5 and we are doing day 3 and that is continuing on dividing polynomials. So we will be working with the remainder and factor theorem and then to find remainder and factors of the polynomial. So we're going to be doing day 3, 6.5 and finish the lesson today. So let's have a look at what the remainder theorem and the factor theorems are. So the remainder theorem says that if a polynomial is divided by a linear divisor, the result can be written as the divisor times the quotient plus the remainder, which is the way that we have been writing our answers. I hope you recall that. And that R right here at the end stands for the remainder. So it basically means that when you do the division using synthetic division, and if that little bracket, remember that little bracket? If that number ends up being a zero, then you don't have a remainder. But if that number is anything other than 0, you will have a remainder. So basically that's what it means. And then factor theorem is just the opposite of that. Basically, it says that if you have 0, you have a factor. So if you have a 0, then that number that you put outside the divisor, a, is actually a factor of the polynomial p of x. So remainder of 0 means it's a factor. If you have a remainder other than 0, then you have a remainder. So basically that's what those two theorems are. Let's take a look at this specific example 1, so we could take further look into this two theorems that we just reviewed right now. So here we have the polynomial coefficients are 1, 8, and negative 48. And then the factor is x minus 4, but the 0 is actually x equals 4. So we need to put 4 in the front, as in we need to put the 0 form, not the factor form. So first step again is to bring down the 1 and then multiply. 1 times 4 is 4, and then we combine 8 plus 4 is 12. Then we multiply 12 times 4 again, that will give us 48, and then we have a remainder of 0. So in fact, because the remainder is 0, then we can answer the question. It says determine whether the given binomial is a factor. So because we have a remainder of 0, then the answer is yes, x minus 4 is a factor of the polynomial. And that's the end of example 1. Why don't you guys go ahead and try this problem right now in the same way that we just did the other one so that you could practice this. Hopefully you've had a chance to try it. Let's go ahead and work it out. The coefficients are 2, negative 6, and negative 1. And the factor is x plus 5, but then the 0 is actually x equals negative 5. So we're going to put negative 5 outside and then bring down 2 and multiply. 2 times negative 5 is negative 10. Combining negative 10 and negative 6 is negative 16. And then multiply negative 16 times negative 5 is actually 80. And 80 minus 1 is 79. So the remainder is not equal to 0. Therefore, what is the answer? Is this a factor? No. X plus 5 is not a factor. Okay, so now you've taken a look at the yes and a no answer. So you know the difference between the two. Let's go ahead and look at example 2. Determine whether the given binomial is a factor. That's exactly what we just did. So we're doing what we just did earlier. And then if so, if the answer is yes, find the remaining factors. That means we need to keep going until we find all of the factors. So we're not only going to do what we did in the previous problem, but we're going to do more. So let's go ahead and set up the polynomial. We've got 1, 3, negative 4, and negative 12. And x plus 3 is the factor. That means we got to put x equals negative 3 in the front here. And then we bring down the 1 and multiply. That's going to give us negative 3. And then when we combine that, that should give us 0. 0 times negative 3 is 0. Combined, we have negative 4. Negative 4 times negative 3 is 12. And then we have a remainder of 0. So the answer is yes, because we have a remainder of 0. But now we got to keep going and we need to find the rest. So we need to find the quotient, the rest of the answers. So the quotient is going to be x squared, reducing it by x squared, and then this is 0, and that's x. So we actually have the polynomial can be written as x plus 3, the factor, times the quotient, which is x squared minus 4. The 0x is gone. And so we're going to factor this further. And using what we have learned previously, this is a difference of squares. So we're going to factor it into two parentheses, x plus 2 and x minus 2. So we have completely factored this polynomial. And so the second part, which says find the remaining factors, these are the remaining factors. So there are 3 factors here that will give us 3 zeros. But for right now, we're going to just leave it in factored form. And that's the end of the problem. Let's take a look at another example. And again, we're going to try to find out if x plus 1 is a factor. And if so, then we're going to find the rest of it. So we're going to set up the synthetic division. 1, negative 4, negative 6, 4, and 5. So there's 5 coefficients. And then since x plus 1 is the factor, then x equals negative 1 is going to be the 0. We're going to put that in front. We're going to bring down the 1 in the first term and multiply. That will give us negative 1. And then combine, we have negative 5. Negative 5 times negative 1 is 5. Then we have negative 1 times negative 1. It's going to give us a 1. And then combining, we have 5 and then negative 5 and 0. So since we have a remainder of 0, the answer is yes, x plus 1 is a factor. So we're going to write the rest. So it's x cubed, reducing it by 1. So we got x cubed, x squared, x, and then 5. Notice that we have here a 4-term remainder. So 4 terms means, remember, that we need to factor this by grouping. So we're going to factor this, separated this, and so the GCF between those two is x squared, and then we have x minus 5. And then between those, remember, we have to group this. So factor by grouping, we need to change the sign here because that's a negative right there. So we need to be able to get back to the original. That will give us negative times negative is a positive 5 back. So what do you have in common? That's only a 1 in common. And then we got x minus 5. Now we have the x minus 5 in common. We're going to pull it out. And then what do we have left? We have x squared minus 1. And then don't forget we have this original factor in the front. So we can rewrite this as p of x is equal to, right here, this whole thing. But we are not done yet. If you take a look at the last factor that we just found, that is actually a difference of square. So we can actually factor this into x plus 1 and x minus 1. And then we're going to bring the rest of it down. So that's going to be x plus 1 times x minus 5. So there's actually 4 factors. So that would actually make sense because notice that the degree is 4. So which means we should have 4 factors. So there they are, the 4 factors. So this is the complete list of factors for this polynomial right here, given. And go ahead and try this problem on your own. So pause the video, do it on your own first before you check your answer. Let's take a look at the answer here. We're going to write the coefficient. Notice that we are missing an x squared term between all of them. So therefore, we're going to add a 0. So we have 2, 8, then 0, 2, and 8. And then the factor I have that we're going to test is x plus 4, which means we're going to have x equals negative 4 in the front. And bring down the 2, multiply, we got negative 8, and then we have 0. Multiply negative 4, that's a 0. Combining, we have a bunch of zeros. Then we have 2 times negative 4 is negative 8. And finally, we are left with a 0 as a remainder, which means, yes, x plus 4 is in fact a factor. And let's go ahead and reduce and write the quotient. So we got x to the third, x squared and x terms are gone, and then we have 2. So the polynomial function can be written as the divisor, which is x plus 4, times the quotient, which is just 2x third plus 2. And we're almost done here, except that there is a 2 in the front that we can try to multiply. And so let's go ahead and factor out the 2. There's a GCF of 2 here, and we're left with x cubed plus 1. Now, if you recall, this is actually a sum of 2 cubes. So we can actually factor this further into 2 parentheses, one big, one small. So we got x plus 1, and then square the first one, change the sign to minus, multiply the 2, that's x, and then square the last one, that's a plus 1. And then putting everything together, don't forget, we have p of x equals this 2 that we have, and then this first factor that we found. And just double checking, we have x squared plus 1, that's x to the 4th together. So everything should be there. And this is the complete list of factors for this polynomial function given. And that's the end of problem. Here's another one that you can try. So make sure you guys try it before you check the answer. And here is what I have for an answer. So we're missing an x squared term, so we're going to add a 0 there. So it's 3, 0, negative 2, and then 5. And don't forget, x minus 1 is the factor, which means x equals 1. So we're going to put 1 in the front, and then bring down the 3. We have 3 times 1 is 3. Combining with a 0 is 3. Multiply again, we have 3. Combining, we have 1. 1 times 1 is 1, and we have 6. Since this is not equal to 0, the answer is no. X minus 1 is not a factor. And we don't need to find the rest of it because it's not a factor. So that was the end of that problem. Here's a discussion problem. What are some ways to divide polynomials, and how do you know when the divisor is a factor of the dividend? So we have actually previously used long division to divide. That's one method. We can actually use synthetic division that we just learned. And we can try also factoring. So factoring, if it works, then we don't have to do the division. And we also, under the factoring, we can have a difference of square, the difference of the sum of cubes, and the difference of cubes, and also factor by grouping. So those are the different ways to factor, or just generally factoring by GCF. So those are the ways to factor. But how do you know when the divisor is a factor? So when you have the remainder equals to 0, that's when you know that it is a factor. So basically it comes to that. When the remainder is equal to 0, you will have a factor of the polynomial. And that is a wrap for 6.5 and a wrap for the entire module. So we're all done with module 6. Hopefully you learned a thing or two, how to properly add, subtract, multiply, and divide polynomials. Go ahead and get started with your Google Classroom homework by logging in, and have a great day.